Okay, so now we're going to talk about are these Blas libraries. So Blas stands for the basic linear algebra subprograms, and also LPACK libraries or linear algebra package. And this is, if you do any kind of matrix operation, multiply matrices, if you SVD a matrix, if you Chol2 inverse, a Cholesky factorization, it's calling these libraries. LPACK is the one that does things other than multiplication. So LPACK is the one that's going to be doing the SVD, things like that, Cholesky. And Blas is going to be doing things like multiplying a matrix by vector, doing a dot product of a vector, matrix-matrix multiplication. It has 3 levels. The third level is the matrix-matrix level. And that will have some special ways to accelerate it, and we'll talk about later. I think it's a good idea never to use the shared libraries that R comes with. It's just the standard ones are super slow, and there's so many options that are optimized available out there that not only will run faster using a single core, but also can take advantage of all the cores you have on your CPU. OpenBLAS is very popular, and yeah.
Oh, what do you mean by shared libraries? Like
Oh, okay. So a shared library is if you have a program in C or Fortran and you just want to run it from the command line, you can compile it as a whole program, and that program will just run straight through, output whatever it's going to do, and then end. A shared library is a collection of functions that when you compile it, it allows other programs to call them dynamically. So I write a matrix-matrix multiplication program. I compile it differently than I would if I just wanted to multiply 2 matrices, output the answer, and then end. I compile it as a shared library, and so that lets me then, if I'm running R, I can call that function, and it can use it on whatever inputs I'm giving it, and I can use it over and over again. And it's just a kind of dynamic linking library. Yeah?
Is that why when you compile C code, you use the R shared library command?
Yes. And so I'll give some commands on how the R shared library command, you can see what it actually does. It does 2 steps, and there's some flags you do in your C compiler that can generate the same kind of shared library without using the shared library command, but it does the same thing. So yes, that's why it's different than just. So OpenBLAS is, Julia has fast matrix-matrix operations. Its linear algebra operations are fast because by default it uses OpenBLAS, and R doesn't. So this is really, I think, the easiest to use. It's completely free, but there are other options out there. Intel puts out this math kernel library, which is free for students. You can actually download a whole, it's called the Intel Composer XE. I forget what the full name is, but that whole thing is free for students, and it actually also comes with Intel's compiler, which is ICC, which I definitely recommend this. This is great, especially if you're running on Intel CPUs, but it'll work on anything. AMD puts out its own library also. Oh, all of these, by the way, have both Blas and LPACK in them. And AMD puts out this one that's the newest version is GPU accelerated, which you need to be using AMD hardware to take advantage of that. And this is free for everyone, but there's a lot of others. Atlas is a very popular one. Atlas does not come with LPACK, and so it's a little more effort to use because you then have to give R a separate LPACK library in it. So if you have any question on these, I'm not going to go on the details of how to swap them out. There's kind of 2 alternatives. This presentation, I do everything in Linux, and so the one thing I'll mention is that this command I give is really a Linux command, but there are probably ways to do it in Windows or Mac, since it's Unix, probably has a similar thing. So R can be compiled from source, and when it's building, you can tell it what Blas library you want. And this is really the way to do it. I say recommended for Intel's MKL, but I've even seen a huge difference when using AMD's Blas library compared to this other method, which is dropping in the Blas library. And that's, if R is built, if you look in the folder that R is in, there's this lib folder, and it'll have 2 files in it. And this is I'm not sure if you do the standard binary install, it should produce these. But if it's compiled and told to use a shared Blas library, you'll have these 2 files in it. And these can just be swapped out for any other one. When I was testing a lot of libraries, I use this update alternatives, which really creates a link and then lets you swap out what the link is pointing to very easily. And so you can just do an update alternatives config command, choose which one you want, and then rerun R, and it'll do it right away. If you have questions on compiling R, let me know. I can help you out with that. Using MKL is fairly difficult. OpenBlast is, let me just go to the next slide. OpenBlast is very user-friendly, and I had no problem compiling R using OpenBlast. MKL, one very important thing is that you really need to use a C compiler when you compile these functions. When R needs it, you need to tell it to use ICC instead of GCC, or else the performance is going to take a huge hit. Even if you're compiling your own functions, if you're ever using Intel's MKL, I would say to use their own C compiler. Now this is great that ACML has GPU acceleration. I haven't fully tested it with the best hardware because I actually built a new computer and I chose an NVIDIA card, and I'll show some results on that. But the way ACML chose to do things, they use this Lua language for scripting on whether or not to use the GPU, and that can be very, very slow. So actually, even after 6.1 came out, I continued to use 5.3.1 just because it was faster if you're not offloading to the GPU. And I also had a weird error. If the matrix is too large, SVD and R would just crash. I think it would seg fault or something. And yeah.
Oh, I guess I have two questions. So let's say using the OpenBlast.
Yeah.
It's literally as simple as swapping out those two files.
Yeah.
And I can just write my code as I usually would.
Yeah, and our program will just run straight away. One thing you do need to make sure is that there's some environmental variables you may need to point it to. I think if you literally copy over the files, you might not need to do this. Say you're on Windows and you copy over these. I think in Windows it's .dll. If you copy over those files, you might not need to do this, but you may get an error if it doesn't know at runtime where to look for some of the files that OpenBlast needs. But once you do manage to copy out these files, literally our code will just run exactly the same, and every time you do a matrix operation, it'll just use the different library. Because all the BLAS libraries have the same function names. And so when it calls these shared libraries, that function it calls from a different library.
How much speed up are we seeing?
I mean, you're talking...
How big does the matrix you have to get? Let's say you're inverting something.
So for CPUs, multi-core CPUs, I mean, it'll be faster for anything. Like literally anything. And OpenBlast can choose the number of all these good BLAS libraries will choose the number of cores it uses for a certain size. And so it's going to be just absolutely faster for everything. And it's going to be way, way faster for large problems. I mean, I'll show a little comparison on the performance, and I don't even include the stock R libraries because they would just be tiny little slivers on the graph. They won't come anywhere near the peak performance for one core, and they'll come really nowhere near the peak performance if you're using all the cores.
And then another, sorry, if I were to try to use this with the HPC cluster, how difficult is that?
So you can, if you wanted to use it for the HPC cluster, you can compile things, and you can't install them system-wide, but you would be able to build BLAS on the cluster in your home directory, and you could, I think there's a command, I'll talk about it for loading the NVIDIA BLAS. I think there's a command that you could give it that would use the BLAS library you compiled. The problem is you need to give it the right number of cores because there's a potential you could take up all the cores on one of the blades of that server, which people would not be happy with. So for that, you really need to consult Chris and Terry. But the next one, and I need to start going.
So what's the speed between can you back to the last one? What's the speed between the OpenBlast and the MKL?
So those are actually the two that I'm going to compare. So I'll show you those. And the third thing I'll compare is this NV BLAS. This is awesome. I was very excited with this. This only accelerates level 3 BLAS calls, which are matrix calls. It intercepts them. So it's not a full BLAS library, but you can have it preload it. So if any call, this gem is general matrix, this is symmetric rank K update, permission rank K update. These are for triangular matrices, symmetric matrices. It'll intercept it, offload it to the GPU, and what's great about this compared to the ACML GPU offloading is that it uses unified memory, so it's never copying over the entire matrix. It's actually keeping it in the CPU RAM and doing the transfer entirely over PCI Express lanes, which I say here, if you have an old computer, you're going to be very disappointed if it has PCI Express 2.0 and you put a card in here. It's really going to limit its performance because this takes up the entire speed of, this is how the CPU and GPU communicate through these lanes. It would severely limit what it can do. PCI Express 3.0 is the newest one, and 4.0 will be coming out soon. It doesn't include LPAC. There is a project built using CUDA, which will include all those functions. And the very last, I'll show 2 example functions in a little bit for calling C, and I'll use this CUDA library to show what it can do. So using NVBLAS requires a little config file. It's pretty simple. You just tell it where to log, tell it what you're going to drop down to if it decides not to use the GPU, tell it what GPUs to use. You can even actually mix and do this kind of hybrid computation. You can actually have it be performing a matrix operation both on the CPU and GPU at the same time. I usually keep this commented out, but if you know you're doing very large matrices, I've tested this out with 10,000 by 10,000 or so, and it can make a difference. If you know what size, you can play with that. And then this is how I load R. I have a little file that just says this in it, and so I do everything in Emacs. And so there's a variable called inferior R process or R program, which I just point it to a file that says this. And so instead of opening up R as normal, it opens it up, preloading this NVBLAS. And so this preload will allow this to intercept those BLAS calls. And so I think if you're on the cluster, you might be able to use this command with a different BLAS library and allow it to use that BLAS library to intercept also. But that you definitely have to be careful with. So here's a comparison. This vertical line is the theoretical peak performance of, this is built on a computer with the Intel processor I mentioned in the example, so 384 theoretical peak gigaflops per second. And this is using, I also bought a used Titan Black card. So that's what NVBLAS is using for here. In the gray, it says Intel MKL. And this is just run in a C program. This is just to compare. I always test out the BLAS libraries just in a C program that just does the matrix operations, and then I see how it performs in R. That's kind of how I figured out why it's really bad to compile R not using ICC and MKL, is that the performance is going to be way worse. MKL gets to some 80% of the peak performance when you're at 10,000 by 10,000. This is multiplying two matrices of this size. And MKL does way better for the smaller sizes, and then it always wins. But as you can see, if you need to do large matrix multiplications, the GPU, once you get past the thousands mark, just takes off. And then to show you the difference of double versus single precision, if you notice the scale, 0 to 1,000. When we move to single precision, we're now 0 to 2,000. MKL does very well. It literally doubles the speed. This is about 330 gigaflops per second, and this is right at 660. OpenBLAS doesn't seem to do as well on single precision, which is I'm not really sure why that happens, but Intel's MKL is significantly faster. It's the one I would recommend, especially if you can compile R with it. That's what I've started using. OpenBLAS I used for a long time when I couldn't figure out how to compile R with MKL. And if anyone has questions about doing this, I can help you after. So we can get huge performance increases, and this is just worlds beyond using a single core with the standard BLAS library that R comes with.